Hello, knowledge seekers. In this episode of 20-Minute Books, we delve into The Knowledge Illusion, a thought-provoking analysis of how we think we know so much, when in reality, we understand so little on our own. Authors Stephen Sloman and Philip Fernbach tackle the misconception that intelligence is purely an individual pursuit, instead arguing that it's a collective process. They unfold the profound implications of this premise, demonstrating how interdependent we truly are when it comes to knowledge. With Sloman's expertise as a professor of cognitive linguistics at Brown University and Fernbach's insights from teaching marketing at the University of Colorado, the duo brings academic rigor to the table. Not only are they respected educators, but as contributors to outlets like the New York Times, The Atlantic, and Slate, they have left a significant impact on the public discourse surrounding cognitive science. The Knowledge Illusion beckons students of cognitive science, self-proclaimed know-it-alls, and those aspiring intellectuals who fret about the breadth of their knowledge. Prepare to uncover the hidden extents of our collective ignorance and the beauty of shared understanding in today's enlightening exploration. The Knowledge Illusion: Why We Never Think Alone. Introduction. Discover the power of collective smarts. Why you're smarter with others. Isaac Newton once said, "If I have seen further, it is by standing on the shoulders of giants." The stories of intellectual titans like Newton or Einstein often paint pictures of solitary thinkers whose individual brilliance moved the needle of human knowledge. Yet this romantic idea of the lone genius isn't quite how intelligence works, at least not human intelligence. The truth is, our mental prowess owes much to the shared cognitive labor of our societies. Without it, our individual thinking abilities would significantly wane. Embark on an exploratory journey with us as we uncover the essence of our collective intelligence. Along the way, you'll encounter thought-provoking revelations. You'll understand that unlike the autonomous Venus flytrap, we are interconnected beings, deeply entangled with one another's minds. You'll trace the evolutionary path that led humans to acquire such robust brains. And you'll be intrigued to realize why a pig's essence can't be reduced to a mere collection of swine-specific genes. Part 1. Unveiling the bike mystery, peeking behind the curtain of our assumed knowledge. You're likely confident you know how to ride a bicycle. It's second nature to many. But what if I asked you to explain the mechanics behind it? That's where things get wobbly. The reality is, we often overestimate our understanding of everyday objects and concepts. This disparity between what we think we know and what we actually know is known as the illusion of explanatory depth, or IOED. Let's cycle through an example. At the University of Liverpool, psychology professor Rebecca Lawson conducted an experiment that would make anyone second-guess their mechanical know-how. Students were given drawings of incomplete bicycles and instructed to fill in the blanks. Sounds simple, right? However, the task revealed surprising gaps. From bicycles with extra pedals to those missing essential parts of their frames, the students' sketches were faulty contraptions that wouldn't hold up in real life. Through their muddled drawings, the students were faced with a stark insight. Their presumed depth of understanding was only surface level. This is IOEB in action, believing we know more than we truly do. And bicycles are just the tip of the iceberg. Other studies have shown that our presumed expertise extends to a range of common items, from the workings of zippers to the intricacies of wristwatches. It's a humbling realization that our personal knowledge vaults might not be as full as we assume. This brings us to a puzzling query that once baffled cognitive scientists. How much do we truly understand? Part 2. Rethinking the brain's hard drive. Our minds aren't built to be encyclopedias. In the era of transformation, the 1960s and 1970s saw cognitive scientists analogizing the brain to the era's hallmark innovation, the computer. This parallel suggested that perhaps The brain functions similarly, serving as a reliable vessel for data storage and processing. Alan Turing and his contemporaries shaped this line of intersecting thought, comparing mental processes to algorithmic computations. But cognitive science was in for an upheaval when, in the 1980s, a pioneering mind named Thomas Landauer challenged this framework. Landauer was fascinated by the idea of quantifying human knowledge in the same units as computer data, bytes. His approach was creative. For instance, he gauged the byte capacity needed for an adult's vocabulary and expanded on that to approximate the whole knowledge cache one might hold. His meticulous calculations converged on an astonishingly modest figure, about 1 gigabyte. Despite its meager impression, even multiplying this by 10 would render it hardly comparable to what modern computers can store. It illustrated a pivotal realization. Our brains are not primed for storing endless information. This insight, though groundbreaking, resonates with what we understand today about evolution. Our brains didn't evolve to be exhaustive libraries of data because our world, in all its grandeur, is simply too complex. Take modern airplanes as an example. No single person grasps every engineering nuance. They're a product of collective expertise. And the complexity doesn't end with human inventions. The natural world presents mysteries aplenty, from the mechanics of weather to the whys of love, to the enigma of ice's slipperiness. These allude to the fascinating limits of our individual brains. Naturally, this provokes a compelling question. If our brains didn't evolve to store information, what is their evolutionary fort? Part 3. Brains on the Move, Unpacking the Evolutionary Purpose of Our Minds. Let's consider a thought-provoking comparison. A Venus flytrap and a jellyfish. One is rooted and plant-like, snaring insects. The other, an aquatic drifter sporting stinging tentacles. At the core, what sets them apart? It's the capacity for action. This distinction isn't minor, it's critical in understanding the evolutionary trajectory of brains. A jellyfish, equipped with roughly 800 neurons, can do something the Venus flytrap cannot. It can act. Though its neural setup is modest, it provides the ability to capture prey and generally be mobile in its watery domain. The flytrap, lacking neurons, is bound to waiting passively for its meals. Progressing up the ladder of complexity, the number of neurons correlates with an organism's range of potential actions. Insects buzz around with thousands of neurons, managing feats like flight. Rats, boasting millions of neurons, exhibit more sophisticated behavior, including nest building and navigating mazes. Humans stand on a towering neuron pinnacle with billions, which propel us into realms inconceivable to simpler beings, like orchestrating a symphony or exploring the cosmos. Despite these vast neural leaps, at its essence, the human brain evolved with one central purpose: enabling action, akin to why that jellyfish boasts its modest neural network. Beyond the rich tapestry of neurons and the broad spectrum of actions they enable, what elevates humans above other creatures? Causal reasoning could be the key. We navigate the world not only by forecasting the outcomes of present actions, but also by deducing the causes behind current situations through diagnostic reasoning. This ability, imperfect as it may be, allows us to untangle the complex web of causality that shapes our world. Indeed, humans may be unique in this sophisticated level of reasoning. As we journey deeper, we'll explore how this distinct capacity for diagnostic reasoning has positioned us to flourish in a world that rewards insightful action. Part 4. Stories as a Bridge, Connecting Cause and Effect in Our Understanding. Let's ponder a Yiddish anecdote about a clever shopkeeper confronting vandals. After repeatedly finding graffiti on his storefront, the shopkeeper begins to pay the culprits, first generously, then meagerly, until they lose interest in their paltry earnings and cease their vandalism. This tale isn't just a wry reflection on human behavior, but also a commentary on the challenges of diagnostic reasoning, breaking down effect to root cause. If the vandals were confused about their motives, you can imagine how tricky it is for us to navigate causality. Predicting the outcome of a cause is typically intuitive. For instance, we understand that poor eating habits might lead to health issues, but it's often a brain teaser to deduce the underlying cause from observed effects, the same way it would be to link abdominal pain specifically to an ulcer without further evidence. Despite its complexity, it's the human capacity for diagnostic reasoning, understanding the why behind the what, that's been instrumental to our evolutionary success. This form of reasoning, intricate and nuanced, sets us apart from other species and is a cornerstone of myriad human achievements, from medical diagnosis to the pursuit of scientific knowledge. Another insight from our Yiddish narrative highlights the unique power of storytelling. Stories are not mere entertainment. They serve as the framework through which we seek to understand causal relationships. Through stories, humans trace origins, as seen in creation myths like the Genesis, and project futures, as envisioned through science fiction and dreams of utopias. These narratives tap into our ability to contemplate counterfactuals, the what-ifs of life. They encourage us to consider alternatives and drive change. Without this narrative-driven cognitive leap, the transition from monarchies to democracies might never have occurred, and astronauts' boot prints would be absent from the lunar surface. Stories, it seems, are the scaffolding on which we hoist our causal reasoning, allowing us to decode the world and reshape it one narrative at a time. Part 5. Our Dual-Track Minds. Navigating the Intuitive and the Deliberative. Consider a brain teaser. Name an animal that starts with the letter E. Doubtlessly, elephant springs to mind for most, as if on cue. This reflects the intuitive groove of our cognition, quick, effortless, and often reliable. But our minds don't just operate on autopilot. There's another gear to our thinking: deliberation. Understanding the routes our minds take can explain a lot about our cognitive landscape. When faced with questions or challenges, we engage in either intuitive reasoning or its slower counterpart, deliberation. The speed of your elephant answer is a testament to intuitive reasoning at work, the same process that sometimes tricks us with the illusion of explanatory depth. Intuition is often a dependable ally, getting us through daily interactions without much fuss. However, it's not infallible. For a mental workout, let's try this puzzle. A bat and a ball cost $1.10 in total. The bat is $1 more expensive than the ball. What's the cost of the ball? The quick, intuitive shot might be 10 cents. But pause and calculate, and you'll find the correct answer: 5 cents. Many of us default to intuition because it's streamlined for everyday life. But when complexity escalates, say when delineating the components of a bicycle rather than simply cycling, intuition can skid to a halt, and deliberation must take the handlebars. Now, if you approach the bat and ball problem methodically and untangled the correct answer without haste, then you may have a predilection for deliberation. Those who deliberate crave details and are seldom swayed by the illusion of explanatory depth. It's not necessarily that they have more knowledge. Rather, they are more mindful of their knowledge limits. They'd likely admit up front they're not bicycle design experts. In stark contrast to the personalized nature of intuitive hunches, deliberation thrives on communal cognitive effort. Even amidst solitude, a deliberative mind debates with an inner community of knowledge, an internal dialogue reminiscent of an exchange between individuals. As we will explore, this tendency to externalize cognitive tasks reveals profound insights into the ways we scaffold our thoughts with the support of our communities, enriching and deepening our capacity for understanding. Part 6. Mind, Body, and World, the Triad of Thinking. Engraved in the annals of philosophy is René Descartes' axiom, cogito, ergo sum. I think, therefore I am. Descartes separated the act of thinking from the physical realm, suggesting our essence lies in thought rather than body. This line of reasoning heavily influenced the early cognitive scientists, who assumed the mind operates in a vacuum, detached from our physicality and our surroundings. As research delves deeper into the wonders of the mind, a new understanding emerges. Thinking is not confined to our craniums. Our bodies and our environment become extensions of our cognitive process, effectively becoming instrumental parts of our mental toolkit. Consider routine expectations. We trust that the sun will greet us each morning, and gravity will maintain its dependable pull. This trust offloads a chunk of memory onto our environment because we usually don't need to mentally catalog constant details like where the couch sits in our living room. A quick scan is all the recall we need. When it comes to complex computations, we similarly recruit the outside world for assistance rather than exclusively working things out in our heads. Picture outfielders in baseball who rely on their perception of the ball's trajectory, a blend of movement, gaze, and instinct, to position themselves for a catch, sidestepping intricate physics equations. This concept of using our bodies and actions to support thought is known as embodiment. It throws light on the notion that thinking isn't just an esoteric activity happening internally but is intertwined with physical actions. This is why children instinctively count on their fingers, and why adults often turn to pen and paper for solving math problems or organizing thoughts. Emotions, too, serve as cognitive anchors. We're spared from memorizing an exhaustive inventory of dangers. Instead, visceral reactions like disgust instinctively caution us against foul water or rotten food. These emotional and bodily responses step in for explicit knowledge, guiding our interactions with the world. Through embodiment, we recognize that we're not just cerebral vessels, but beings who think with every fiber of our being and every piece of our environment, creating a dance of cognition that's as embodied as it is broad. Part 7. Together we thrive. How social bonds shaped human smarts. Ever marvel at the towering intellect of humanity, the collective force that envisioned the pyramids, decoded the human genome, and penetrated the mysteries of space? Our journey from hunter-gatherers to creators of civilization hinges on one defining catalyst: our remarkable knack for collaboration, rooted in what's known as the social brain hypothesis. The hypothesis posits a direct link between our ancestral social interactions and the ballooning of our brain size. Primitive survival in groups meant tackling challenges that demanded increasingly sophisticated cognitive solutions. As our proto-human predecessors banded together for hunts or shared resources equitably within the tribe, the intricate social dynamics necessitated an intellectual leap, and our brains expanded in concert with these social complexities. Anthropological evidence, like that gathered by Robin Dunbar, lends weight to this theory. Observations show a compelling pattern across primate species. Larger social groupings tend to equate to larger brains. Our multitude of neurons, thus, seem to have blossomed alongside our ancestral cliques and communities. The impact of communal life on our species wasn't just a matter of brain size. It sculpted us into master collaborators, setting the stage for the division of cognitive labor. Consider the contemporary construct of a house, an edifice that would crumble in the absence of specialized skills ranging from architecture to plumbing. Each practitioner contributes essential expertise, and while a generalist might cobble together a rudimentary shelter, only through combined specialized knowledge do we achieve the comfort and security our homes afford us. This specialization is made possible not just because each task carves its niche, but due to shared intentionality. Every electrician, every bricklayer, every carpenter plays their part towards a common crescendo: the construction of a house. In this choir of collaborative endeavor, from the sleek devices in our pockets to the rockets piercing the heavens, two human faculties play a leading role: the division of cognitive labor and our shared intent. It is these twin threads of collective intelligence that weave the tapestry of our species' spectacular feats. Part 8. Between Tools and Partners. Why Machines Can't Align with Our Goals. Imagine the scenario: a driver, fully reliant on GPS navigation, veers off course and ends up marooned in a lake. Absurd as it may sound, this kind of mishap isn't as rare as one might hope. It begs the question, where does the fault lie? With the tools we've grown to trust almost unconditionally, or with us for anthropomorphizing them? As humans, we're innately adept at integrating tools into our routines, using them as seamless extensions of our own bodies. Think about how naturally you might wield a pen. You sense the ink flowing onto the paper, not the grip of your fingers. Modern technology, however, has morphed into a domain beyond traditional tools. Our gadgets converse, guide, and update themselves as if they possess a will of their own, veiling their true nature as inanimate objects. This blurring leads us to mistakenly ascribe to these devices the human ability to share intentionality and understand our goals. But even the most sophisticated navigation system doesn't truly want you to reach your destination. It's devoid of desires and purposes. A GPS can't aspire or align with objectives. It simply executes calculations. And when that uncritical obedience leads you astray, it's a stark reminder. Technology can't partner with humans in the genuine sense. Looming over these misunderstandings is the specter of a superintelligence, a machine or system so advanced that it overshadows human intellect, potentially endangering humanity itself. Thought leaders like Elon Musk and Stephen Hawking have sounded the alarm, fueling dystopian visions of a technology-triggered downfall. But for all the apprehension, the emergence of such an entity isn't a pressing threat. The secret source to our cognitive evolution, collaborative instincts, and intentional alignment remains outside of machine capacity. Computers process data at staggering speeds, but they lack the grounding in shared purpose that propels human societies. We're a long way from engineering devices that genuinely encapsulate our collaborative spirit and willingness to converge on common aspirations. As it stands, we might do well to shake off our over-reliance on mechanical minds, enchanting yet limited, and revisit the depths of our own interactive, intention-sharing brilliance. Part 9. When technological terrors take root, challenging the tide of anti-science fears. It's in our nature to fear the unknown, and the swift march of technology often blares like an alarm through our collective comfort zone. The thought of a super-intelligent AI, while far-fetched, can indeed be chilling. But a line exists between rational caution and irrational fear, the latter stirring anti-scientific sentiments that can be tough to dissipate. Take the case of genetic modification, which ignites widespread trepidation despite its potential benefits. For many, the dread surrounding genetically modified organisms, GMOs, is as visceral as aversion to pathogens. This is reflected in studies where participants exhibit markedly higher opposition to GMOs in food compared to in non-ingestible products, revealing an undercurrent of misunderstanding, equating genetic material with contaminants. Addressing such fear isn't straightforward. Walter Bodmer's deficit model suggests that apprehension towards novel technologies is rooted in a lack of understanding. It proposes a seemingly logical remedy: bridge the knowledge gap, and people's unfounded worries should wane. Yet despite earnest efforts to educate, resistance to GMOs remains stout. Why? Because even as we clarify that introducing a pig gene into an orange tree won't spawn piggy oranges but fortify them against diseases, the misconception prevails. At the heart of this issue are our flawed causal models. Common practices like cranking up the thermostat to heat a house rapidly demonstrate our intuitive leaps. The connection feels so logical. If more faucet twist yields more water, why shouldn't more thermostat lead to more heat? Though factually wrong, the intuition is potent. The same faulty models ensnare our perceptions of GMOs. They trip our imagination, conjuring absurd scenarios where genes impart their source's attributes, a misunderstanding that remains stubbornly resistant to correction. In this landscape, pulling up the weeds of anti-scientific sentiment turns out to be as much about nurturing a deep, nuanced understanding of cause and effect, as it is about confronting the phantoms of science fiction become perceived science fact. Part 10. Escaping the Echo Chamber. How Causal Thinking Can Combat Groupthink. The annals of history are shadowed by the question of how ordinary people could support regimes like those of Stalin, Mao, or Hitler. These leaders, whose orders caused untold suffering, seemingly commanded the unquestioning backing of the masses. The phenomenon, known as groupthink, sees communities harmonize their beliefs to the point where dissent becomes inconceivable. This uncritical conformity can lay the groundwork for some of history's darkest chapters. To steer clear of such collective blunders, one countermeasure is fostering deeper comprehension of governmental policies. In essence, work on grasping the principles or acknowledge the limits of our own understanding. An investigation carried out by the authors throws light on this very prospect. Participants were asked to critique or endorse an array of policies like sanctions on Iran, and then to explain the causal underpinnings of their anticipated outcomes. Struggling to articulate these pathways, many staunch supporters or vigorous opponents of the policies moderated their stances when prompted to reassess their positions. Thus, nurturing a more nuanced understanding of causality in policies can potentially narrow political rifts. Yet, some convictions stand firmly rooted, immune to causal reasoning, and are predicated on what's known as sacred values. Deeply held beliefs that are resistant to change. Consider the impassioned divides over abortion. Activists on either side are driven less by policy outcomes and more by indelible principles. Politicians, attuned to this dynamic, may opt to sidestep complex policy details in favor of rallying speeches that invoke sacred values, a strategy that can sway voters without delving into the nitty-gritty of legislations. But this shorthand approach has a flip side, as it can divert attention from critical examination of the policies themselves. In this context, appreciating the power of causal reasoning and recognizing the manipulation of sacred values become crucial tools in the hands of an informed electorate, helping to illuminate political discourse with a clarity that can transcend the simplicity of groupthink. Part 11. Redefining Intelligence. Embracing Collaboration in Learning and Thinking. Martin Luther King Jr. and Albert Einstein. Names that resound as paragons of individual brilliance in civil rights and physics, respectively. Yet, the narratives often gloss over the integral collaborations and preceding groundwork that made their achievements possible. Their stories, though rich and multifaceted, are condensed into a digestible myth of the lone genius, a narrative that overlooks the community of minds behind every great leap forward. This is where we encounter a critical crossroads that requires us to redefine what it means to be smart and to reassess the very structure of education. Considering the evolutionary backdrop where humans flourished not as isolated thinkers but as interdependent collaborators, it becomes imperative to factor in these communal capacities when measuring intelligence. Moving beyond the narrow confines of an IQ score, our redefined metric of SMART should reflect an individual's aptitude to engage in and enhance collective endeavors. This philosophical shift needs to be mirrored in the classrooms. Moving away from rote lectures, we should cultivate learning environments that prioritize interactive, team-based activities that better reflect our cooperative nature. Our perception of schooling's purpose needs expansion as well. It's less about individuals becoming walking encyclopedias upon graduation, and more about nurturing the ability to partake in collaborative projects. True education should serve as a reality check about our own knowledge limits, prompting us to seek the collective intelligence we're enmeshed in. In essence, education isn't just about knowledge acquisition. It's about instilling an understanding of one's knowledge boundaries and the humility to collaborate. This recognition of our inherent interdependence resonates with a broader truth. Our thoughts are not just our own, but part of a vast interconnected tapestry. By reimagining intelligence and learning with this in mind, we pay homage to the communal nature of human thought and progress. Final summary. If you're convinced that you're well versed in the workings of everyday objects or complex concepts, you might be surprised to find that our perceived knowledge often overshadows our actual understanding. Contrary to treating our brains as vessels of vast information, like computers, we're actually wired for something quite different: collaboration and community. Our success as a species isn't a testament to individual genius, but rather to our shared cognitive efforts and our capacity for joint intentionality. Yet our sense of intellect often suffers from illusions, even as we navigate a world where machines cannot align with our intentions and anti-scientific sentiments challenge our advancements. Groupthink can blind us, while the invocation of sacred values by politicians can oversimplify intricate issues. To counter these hurdles, a rethinking of what constitutes smart is essential. We should cultivate an educational culture that doesn't just instill facts but promotes cooperative problem solving and critical thinking, embedding a keen awareness of our collective nature in our approach to learning and progress. In sum, our individual minds gain strength from our combined intelligence. By acknowledging the shared fabric of human cognition and adapting our understandings of intelligence and education accordingly, we honor the profound collective journey of our thinking and achievements. It's a reminder of the insightful message communicated through the knowledge illusion, that the minds we think with are not solely our own, but are intertwined within an expansive network of shared human thought. Thank you for joining me today on this journey of learning and discovery as we explored the insights of another thought-provoking book in our growing library of knowledge. If you've enjoyed our time together, please take a moment to follow our podcast, give us a 5-star rating, and share 20-minute books with other knowledge seekers. Your support truly means a lot. Don't forget to join me again in the next episode, where we will delve into another enriching book. Until then, happy reading and happy listening.